2, 3, 4, 1 multiplied with 1, 2, minus 1, 3. Multiply and write your answer. Directly multiply and write your answer. 2 minus 3 minus 1. 4 plus 9, 13. 4 minus 1, 3. 8 plus 3, 11. Fine with everybody? This is called matrix equation. Observation number 1. If we interchange the rows of all three matrices, what will happen? Just interchange it. 4, 1, 2, 3. Minus 1, 3, 1, 2. Is it equal to C or not? You have to check. If you interchange here, 3, 11, minus 1, 13. Are they equal? When you multiply, then you notice that they are not equal.
No, they aren't.
Observation number 2. If we interchange rows of matrix A and C, if you interchange rows of matrix A and C, that means here there will be a change. 4, 1, 2, 3. But B is kept constant. No change in B. And even in the right hand side, interchange the rows. 3, 11, minus 1, 13. Check, are they equal here? Are they equal?
Yes, sir.
Yes, sir.
So which is true? Which is true. Now observation number 3. Can I remove the first observation?
So one first you can observe.
Yes, sir. First, sir.
Now observation number 3. If we interchange rows of B and C, that means A is kept constant. Will they be equal? Minus 2 plus 3 is not giving you 3. So they will not be equal. Now you will write the conclusion after that. Can I remove the observation number 2?
Yes, sir.
Yes, sir.
Now write conclusion.
Yes, sir.
conclusion. In the matrix equation, either you can write AX equal to C or AX equal to B, or B is equal to AX. X is the unknown or X is the matrix. We can interchange the rows of A and B. A means the first matrix here and the first matrix on the B right hand side. But matrix X should not be changed. Is it fine with everybody? Understood the first conclusion?
Yes, sir.
Yeah. Anyone in the class who has not understood this concept?
No, sir.
Okay, now look at it. Who is going to take the lead now? I want one student to always take the lead in the class. Now, Parinita was speaking throughout. Now I want somebody else to speak. Okay, Austin. Austin,
Yes, sir.
finish writing.
Yes, sir.
Okay, yeah. You are going to look at this and tell, I'm going to teach you another operation. You have to help me out in this calculation. I am going to multiply a row with a number. Let's say R1, I am multiplying with a 10. What will happen to the equation? Now you are not writing, yeah? First row transformation I taught you. Now we are going to the second row transformation. So you are not writing, you are listening. Everybody is listening now?
Yes, sir.
Yeah, okay. Now row 1, I am multiplying with 10. What will happen? This become 20.
30.
This become 30. Only row 1 is multiplied. This will become 10. This will become 20.
20.
This will become minus 10. This will become 130. Check and tell me, are they equal or not equal?
No, sir.
Where it is not, where it is going, first element is correct, now. This is correct, now. How much it became? 200 minus 30.
Yes.
No, it is wrong.
200.
Correct.
Yes.
So no
It's not
element is correct here. Am I right? So
Yes,
they
sir.
both are not equal. Now what I'm going to do is, I am not going to multiply the matrix B. Only first one I'm going to multiply. Now check whether they are equal or not. Now check. What do you get the first element first? This row
Yes,
with this
sir.
column.
Yes,
How much you
it's,
get?
Yes, sir. Now it is correct.
20
It's equal.
minus 30. Did you get minus 10?
Yes, sir.
40 minus 90. 40 plus 90. 130 is correct. And of course, last
Yes,
row will be
sir.
always correct. So what's your conclusion now? One conclusion we learned is, in the matrix equation A B equal to C, A and C, what you can do with A and C?
We can interchange them.
We can interchange the rows. Now, one more I've taught you. You can multiply any row with a number. Then also the equation will remain intact. Suppose I divide by 5. Now check whether it's correct or wrong. 4 by 5 into 1 minus 1 by 5 into 3. Do you get this answer? You multiply this both, just check. 4 by 5 minus 1 by 5.
Yes, sir.
Am I getting 3 by 5? So
Yes,
not
sir.
only multiply, you can also divide. But when you divide, which two matrix should change?
A and C.
A and C. What about B?
It should
Remain constant.
B should remain constant. But if I would have divided this with a 10, now I'm rewriting it. 2, 3, 4, 1. Let's say I multiplied this row by 10. Now check whether is it left hand side and right hand side are equal. This and this multiplied 20 minus 3. I'm supposed to get 17. So this will be not be equal. So it is very clear now. Row transformation is always between first matrix. Second matrix should be kept constant. Whether you are interchanging the row or you are multiplying a row with a number. Is it clear to you? Yes or
Yes,
no?
sir.
Yes,
Okay,
sir.
write down now.
Yes.
Yes, any doubt?
No, sir.
Okay, then write down next conclusion. Write like this. Multiply, you write this equation once again. Consider AB equal to C. Write down this equation once again. And what you're writing below it? R1, row 1, okay. Row 1 of matrix A and C are multiplied by 10. So what do you get? 20, 30. Then what is not changing, I'll write in black. 4, 1. 1, 2, minus 1, 3. Then I'm going to again multiply the first row with a 10. Minus 10, 130. 3, 11. Check are they equal? Which is true. So what is the row transformation number 2? We can multiply or divide any row of matrix A and B. Divide by any by a number. By a number.
So this is conclusion.
Yeah, tell me.
This is conclusion.
Conclusion. This is a conclusion. We can multiply or divide by a number. We can multiply, divide a row by a number. Any row by a number of the matrix A and C. Okay, A and B in the matrix equation. In the matrix equation, AX equal to B. Why this X is put as X is always denote the unknown matrix. That's why I write AX equal to B. Equation, there should be something unknown, no? So X is unknown, A and B are known matrix. So in A and B, you can multiply any row or divide any row with a number. Is conclusion clear? We can multiply or divide any row by a number of the matrix A and B in the matrix equation AX equal to B. Is it fine with everybody?
Yes, sir.
Yes, sir.
Yes, sir.
Are you still writing?
Yes, sir.
Okay, I'll just pause for some time. I am going to change the second row. How I am going to change the second row is, I'll multiply first row with a number. Tell me some number. 10 only will take. Why 10? Easy to multiply. Row 2, new row 2 is obtained by multiplying row 1 with a 10 and adding to row 4, row 2, adding to row 2. What will be my answer? First row is not changing. Again, I am not supposed to change B. And here also first row not changing. Only the second row changes. When I write this way formula, R2 is equal to R2 minus 10 times R1, only R2 will change. So R1 is multiplied with 10. So how much this became?
20,
20. Add to it,
24,
24.
multiply
31.
by 10. So 31. I'm not supposed to do anything with the B. It should be kept as it. Multiply with a 10 and add to it. Minus 10
7.
plus 3. So minus 7.
Minus 7.
130 plus 11.
141.
141.
Now we'll check whether they both are equal or not. Look at this. We don't have to check the first row this because they do not change at all. We need to only check whether this is correct or wrong. 24 into 1 plus 31 into minus 1. Do you understand? 24 with this and 31 with this. Am I getting minus 7? Are we getting minus 7? Say yes or no.
Yes, sir.
Yes.
Yes, sir.
Same way, 24 into 2, 48. 31 into 3, 91. Correct? 24 into 2, 31 multiplied with 3, 93. So is it 141?
Yes, sir.
Am I getting the same answer? Yes. So what have you learned by this particular example? What else you can do with the matrix A and C? Tell me. What is this I taught you just now? Tell me the conclusion. What you can do with that? Austin,
Yes, sir.
what did I do here? What did I do here?
You changed row 2 by adding row 1 and multiplying row 1 with 10.
So we'll say like this. Multiply any row with a number and or subtract to any other row the value of the A on A and B, on A and C, the matrix equation will be true. So what is the new operation we can do? Multiply a row with a number and add to another row. This 3 operation which I taught you is called row transformation. Is it clear?
Yes, sir.
So
Yes,
write
sir.
the conclusion. Write the conclusion.
You'd have to write, sir.
Okay, right from the beginning. I'm pausing. Yeah? You multiply row 1 with 10 and add to row 2. We saw the left hand side and right hand side are equal, but the change is only in A and C. So in a matrix equation AX equal to B, what are the things you can do with A and B? You can multiply any row with a number and add to any other row. So in my conclusion, don't write now. In the matrix equation AX equal to B, what all things I can do? 1, I can interchange the second row with the third row. I can multiply a row with a number. I can add 2 rows. I can subtract 2 rows. I can multiply a row number 3 with a 2 and add to row 1. All this operation you can do. Can you do this one? R1 multiplied with R2. Is this allowed? Row 1 and row 2 elements are multiplied. Is this allowed? Say yes or no. Is this a row transformation? Total, how many row transformations are there?
3.
3. Is such an operation possible?
No.
Not possible. You cannot do like this. So don't think of multiplying 2 rows, but you can add 2 rows. So let's practice. Write this one. 2, 3, 1, 4, minus 1, 2, 1, 2, 3. Multiplied with 1, minus 1, 2, 0, 1, 3, 2, minus 1, 1. When you multiply, what answer will get? I'll write down. 2 plus 0 plus 2 gives you 4. If I make a mistake, help me out, okay? Minus 2 plus 3 minus 1. So 0, I suppose. 4 plus 9 plus 1. So 14. 4 plus 0 plus 4. Minus 4 plus 1, 5. Minus 4 plus minus 1, minus 5. Minus 2, minus 7. 8 minus 3 plus 2, 7. 1 plus 6. Minus 1 plus 2 minus 3. 2 plus 6 plus 3. I hope this is correct calculation. 2 plus 6 plus 3. Pandita, did you calculate yourself?
Yes, sir. Last row, I'm still doing.
Yeah, okay, we'll correct it. Now do this operation next row. R2 interchange with R3. R2 interchange with R3. Which two matrices I can change? AB equal to C, it is, no? Which two matrices I should interchange?
A and C.
A and C. Should I do anything with the B?
No, sir.
If I do with B, what will happen? This will become unequal.
Answer
This
will
to
come
left hand
wrong.
side, left hand side will not match with the right hand side. So interchange 2, 3, 1 remain as it is. 1, 2, 3, 4 minus 1, 2. Do not interchange second matrix. Keep that as it is. Then what will happen? Here 4, 0, 14, 7 minus 2, 11, 8 minus 7, 7. Is it fine?
Yes, sir.
Just try interchange, just for fun. And what did I say? Left hand side and right hand side are equal. Naturally, no. See, 1, 2, 3 multiplied with this, you got this. Now 1, 2, 3 will multiply with same and you will get this. Correct or wrong? Logically, you
Yes,
agree?
sir.
Yes, sir.
That's why we are not interchanging the middle one. If you would have interchanged here, then the multiplication combination should have been different here.
Yes, sir.
Okay, now what you do is, now we are not looking at this, we'll look at this. R1 plus R2 you do. R1 plus R2. Which is going to change? R1. Whichever you write first will change. Even if you don't write, this is okay. Whichever you write first will change. Can you write and give me what is the answer? Don't do with the original one. Do with only this previous step. So R1 plus R2, how much will become? Tell me.
3,
3, 5.
5.
5 and
3,
4.
5, 4.
Should I add here?
No.
No. Should I add here?
Yes.
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 4
11,
plus 7, 11.
Minus
Minus
2,
25.
25.
25.
No change here. No change here. No change here. No change here. Now check whether is it correct or wrong. We interchange the first row, no? 3 plus 0 plus 8. Am I getting 11? Yes.
Yes.
Minus 3 plus 5 minus 4 minus 2. Perfectly right. 6 plus 15 plus 4, 25, correct. I hope you are getting the idea.
Yes, sir.
Okay. Then what you do is R3, next one, R3 is 2 times R3. Just multiply the second row with the 2. Third row with the 2. And I don't have space to write. I'll be writing on top. So what are the operation I'm going to do next is I'll write in different color so that you are able to notice. R3 is 2 times R3. Remember, you have to check here. Check and found, checked and found correct. Here also. Checked and found.
Sir, you have to do the next operation with respect to previous, no?
Yeah, previous only, not the original. From the previous only. Continue with the previous only. Okay, I'll do one thing. I'll write with the black the original terms. So no change to this. Change occurs here. R2 is twice, so it became 8 minus 2 and 4. No change here. So whatever no change, I've written in black color. Whatever there's a change, I will write in red color. There will come 16 minus 14, 14. Now check, is it correct? 8 plus 0 plus 8, 16, barabar. Minus 8, minus 2, minus 4, minus 14. 16 minus 6 plus 4, 14. Found correct. Checked and found correct. Finish writing? I want to just remind you, what is a matrix A into I? Do you remember what is I stands for?
Identity matrix.
Identity matrix. So if I have 2, 3, 4, 1, if I multiply with 1, 0, 0, 1, what is your answer? If you multiply 2, 3 minus 1, 1, 4, 1, 2, 1, 3, multiplied with 1, 0, 0, 0, 1, 0, 0, 0, 1, what will be your answer? What will be the answer? First one. Jeff, what will be the answer here? Without multiplying, you are supposed to tell me the answer. Without multiplying. If this speciality of this matrix, this is called unit matrix. It's like number 1. What is the speciality of 1? If you multiply 1 with a number, you will get the same number, no?
Yes, sir. Same number.
Unit matrix also same rule. If you multiply 2, 0, you will get 2. 0, 3, 3. 4, 0, 4. 0, 1, 1. Right? Yes, Raj. Yes, Kevil. You have given the answer. You will get the same matrix. So the speciality of the unit matrix is, if you multiply a matrix with the unit matrix, you will get the same matrix as your answer. Same matrix as your answer. Is that clear to anybody, everybody?
Yes, sir.
Okay. Now my question to is, I'm giving you a question. 3x equal to 7. What is x? What is x? Don't get surprised. It's a simple question.
7 upon 3.
7 upon 3. How did you do that? Is you divided both by 3 and made this side 1. That's how 1 into x. That's how you got the answer. So whenever I have 2x equal to 7, I want to find x. I make this 2 1 by dividing both sides with a 2. Do you agree with that? So if I have a matrix equation ax equal to b, if I want to find x, I'm supposed to divide by a, but in matrix there's no division. Matrix we have addition, subtraction and multiplication, but there's no division. Clear? So I don't have the option of dividing by a, nahi kar sakta hai. This is wrong. Matrix, there's no division. So in a matrix equation, how will I find x? Did you understand the question? Have you all understood my question?
Yes, sir.
What did I say? In an algebraic equation, if I have 2x equal to 9, I need to divide by 2 and make this as 1, and 1 into x will give me x, and that's how I get 9 by 2 as the answer. Fine? But in a matrix equation ax equal to b, I cannot divide by a because there is no division technique available in matrix. Followed? So how will I find out the unknown matrix x? That's what I'm going to teach you. Let's imagine 1, 2, 3, 4.
So right.
No, don't. I'm now today's whatever I want to teach you, I already taught you. Now I'm going to teach you the application. Let's say 1, 2, 3, 4 is multiplied, and I got 7, 11, and 17, and 23. And I want to find out what is the matrix x. How will I solve this equation? The matrix x, I hope you understood. It's not multiplication, it's x. Is it clear to everybody? This is my problem. How will I solve it? How will I convert this into 1? How will I convert this into unit matrix so that I can get x as my answer? I will convert this into unit matrix. Then naturally, whatever the answer I get on the right-hand side will be my x answer. Do you agree with the statement?
Sir, can you repeat it once more?
Yes, sir.
See, listen to me. 3x equal to 5. How to find x value? How to find? I did not ask you what is x. How to find x value?
Divide by 3
Why did you divide by 3?
to get 1.
So that
Get
here
1.
become 1. So 1 into x is x, and I get my answer, right?
Yes.
In matrix equation, there's no division. So I can't divide. So what I'm going to do is, I will convert this matrix into unit matrix. I'll convert this matrix to unit matrix by using row transformation. Okay.
Yes.
And automatically, the right-hand side will give me an answer. Why did I use row transformation? Because in matrix ax equal to b, I can change a and b. This unknown matrix will never change in row transformation. When I apply row transformation, what is the speciality? The second matrix never changes. So even if I don't know this, no problem. I need to only change this two. And what should I do? I should convert this into a unit matrix. Then automatically my right-hand side will be your unknown matrix x. Is this concept clear?
Yes, sir.
Yes.
So we can change like that.
We can change. I taught you this whole thing. What did I
Oh,
teach you
yeah,
in all
okay.
this? I can do so many operations. What are the operations I can do? What are the operations I can do? All
Addition.
operations I can do.
Yeah.
We'll use all this operation and convert that first matrix into unit matrix. Is it fine?
Yes,
Is it
sir.
fine? Okay.
Yes, sir.
Now, if I want to convert into unit matrix, some steps are there. I'm going to teach you the steps. First and foremost thing, the first element should be 1. This element is 1. Wow, I'm very happy. Next is I have to make this 3, 0. Because I want 0 here. No? 3, 0. See my formula. R2 is equal to, second row is going to change. Original R2 is 3. From that, I cannot do -3. There's no such row transformation. I will multiply the first row with the 3 and subtract. Is it fine with everybody? I wanted to make this 3, 0. Do you agree with this statement? I want to make 3, 0.
Yes, sir.
And I cannot subtract 3. There's no such row transformation. But I can multiply the first row with the 3 and subtract. Now my calculation, 1, 2, x. There's no change. 7, 11, no change. Multiply with 3 and subtract. Multiply with 3, 4. Multiply with 3 and subtract. 4 minus 6 minus 2. Are you happy? Are you happy?
Yes.
Yes, sir.
Yes, sir.
If you're not understanding, you must say, I'm not happy, sir. 17 minus 3 times R1. R1 is 7. 17 minus 21. How much you get the answer?
-4.
-4. Then 23 minus 3 times
33.
11. So 23 minus 33, that is -10. Are you happy?
Yes, sir.
So,
Don't worry, I'll teach you a little more. Just to see the technique. Now this -2, I'll make it 1. So R2, I'm going to divide by -2. I'm allowed to divide a row with a number or multiply a row with a number. So I'm dividing by R2. So I'll get 1, 2, 0, 1 into x, 7, 11. This has to be divided by -2. This has to be divided by -2.
yes.
All right.
Yes, sir.
Now I'll make this 2, 0. If I make this 2, 0, this will become unit matrix. So R1 has to change 2 times R2. If I multiply this with a 2 and subtract, this will become 0. And because here it is 0, nothing will happen to this. It will remain as it is. So see what will happen. So naturally, R1, 1 minus 2 into 0 will give you 1. 2 minus 2 into 1 will give you 0. 7 minus 2 into 2 will give you -3. Then 11, R1, yeah. 11 minus 2 into 5 will give you 1. Right? So much is clear. So this is unit matrix. Unit matrix multiplied with any matrix will give you the same answer. So what is your matrix X? What is your unknown matrix X?
-3, 1, 2, 5.
My unknown matrix X is -3, 1, 2.
5.
Is it clear to you? If I put this matrix here and multiply, I will get this answer. If you want, you check. 1, 2, 3, 4 multiplied with -3, 1, 2, 5. Check whether you get the same answer. -3 plus 4 will give you 1. What about over here?
Sir,
It
sir,
will be
sir,
3.
sir, it will be 3, sir, not
It will be
-3.
3. Yeah.
3. Acha, this is 3, na?
Yes.
Calculation went wrong there. 3 plus 4 will give you 7. 1 plus 10 will give you 11. 9 plus 8 will give you 17. And 3 plus 20 will give you 23. I'm getting exactly same answer. Therefore, my X is this matrix. Is it clear to everybody?
Yes.
Yes, sir.
We will practice this in next class. Just I give you introduction only to solve the equation.
Sir, almost
Today-
clear, sir, not 100%.
Yeah, this calculation I have to teach you again. I didn't make you write it. So
Okay, sir.
what I
So
taught
I
you
didn't
today,
write it.
no need of writing. To go next class. Now
Okay.
listen to me. What I taught you today. In a matrix equation AX equal to B, what are the operations that you can do with A and B? Tell me one by one. What is the first operation that you can do? Speak out.
Art, we can interchange
We can interchange the rows. Can interchange rows. Second, You can multiply any row with a number. Third, what is the third operation?
We can add.
We can add.
Multiply a row with a number and add to another row. Any row R1, Ri can be made as a new Ri. Multiply any row with a number and add to another row. If k becomes 1, what will happen? You can add 2 rows. You can subtract 2 rows. You can multiply a row with a 3 and add to another one. All these operations we can do. Did you follow this? These 3 operations are called row transformation. Is it clear? Yes or no?
Yes, sir.
Yes, sir.
With this, we are stopping. Yes. Next class, we are going to practice how to do this operation. I just showed you the application. I have not taught you how to do it. There are so many other tricks to tell you, which I have not spoken. That will be taken in the next class. Okay?
Sir, can you show that slide again? The last
Yes, sir. Last one.
Last one here. This I have already given you writing. Here it is. Here.
Yes,
Here. Yeah, made you write here. Wait. This place.
But one more time clearly after.
Okay. Right.
Sir,
Then.
right. Just a summary, sir.
Yeah. Then again, you write in the matrix equation Ax equal to B. Okay. Those who want summary, write down. In the matrix equation Ax equal to B, we can interchange rows of A and B. 1, 2. We can multiply any row with a number. Multiply or divide also. Third, we can multiply any row with a number and add to any other row of A and B. Here also of A and B. These are the 3 operations. You can't multiply 2 rows, sir. You can't divide 2 rows. Only 3 operations we can do. Fine. Those who want to can leave. Those who are written can leave.
Bye, sir. Thank you, sir.
Thank you, sir.
Bye, sir.
Bye.
Bye, sir.
Thank
Bye-bye.
you, sir.
Bye, sir.